Hello everyone, good evening. Let us discuss today's LeatCode challenge problem. So today's challenge is find the maximum length of a valid subsequence 2. So it is a kind of a variation of the last day's question. Uh, in last day, K was given only 2. So here it is in general K. So we have to actually, the problem is similar to yesterday, just only the value of k has been increases. So if there is any array given, the task is to find maximum length subsequence in which consecutives, if subsequence is A1, A2, A3, like this, AN. So the conditions to satisfy A1 plus A2 modulo K should be equal to A2 plus A3 modulo K equals to A3 plus A2 modulo K, like this. For every consecutive pair, the modulus K value of every consecutive pair should be equal to uh, same. So the task is the same as we have solved yesterday's question. So this problem is generalization of last stage question. So one property we saw last day is that if A1 plus A2 modulus K, then I can write it modulus of individual values plus and whole modulus. So either we take the array that is original array, or we take a array that is the modulus of that contains the elements modulus of the original array. So that will be equal. So this condition will be very helpful to solve this question. So what is the intuition for this question? So if we think about it, any subsequence, let's say we have this A1, A2, A3, AN. So if the modulus value of all these consecutive pair should be equal, in that case, if let's say some k dash value, modulus of A1 is k dash value, modulus of k dash, k double dash value. So the sum of these will be equal to, let's say, some L. Modulus of this value is equals to L. So any two modulus value, mm, let's take this one example, 1, 4, 2, 3, 1, 4. So if we see the modulo values of this element is 1, 1, here k value is equals to 3, 2, 0, 1, 1. So we need to see that if the sequence follows the property, in that case, every alternate LU modulo should be equal. They are the modulo congruent. Because if the modulo value of K1, K2, K3, K4, in that case, if K1 plus K2 modulo K is equals to K2 plus K3 modulo K, in that case, because K2 is same in both. If K1 and K3 are not same, in that case, the modulo values will not be same, right? Because we have K is between K minus 1 and K 0, because at max modulus, after performing the modulus on any element in the array, that value will be in the range of this only. So in that case, this K1 and K3 should be equal. That means any consecutive in any sequence, alternate value or modulo congruent, right? So if the modulo value of this K1, so K3 is also K1, K5 is also K1. It is some K2, and A4 will also be K2, and A6 is also K2, right? So in this, we have to prepare a sequence which has alternate means like if the modular value, let's say alternating between 10 10 or 20 20, or if there is 12 12 also possible, 1 1 1 possible. So let me erase some part of this. So how we like if we go by brute force, that will be little quite costly. We prepare every we prepare a sequence, every subsequence, and check if they are alternating modulo or not. Repeated alternating modulo values. That will be kind of semi brute force type. So the constraint in the problem are given num size is 10 to power 7 and length is 10 to power 3. K is also 10 to power 3. So to solving this question, we need a DP, because if we create all the subsequence of this, it will be kind of exponential time complexity for this question. That is costly and that will be timely used. So we will need to think something else. So in this we will do DP, where DPI J, if for every DPI J, DPI J represents the previous modulo and current modulo. Let's say we are at this position currently. So the modulo value of this and modulo value of this previous value. This dp represents this maximum length of the subsequence, considering the last element in the current position. The dpij represents this. So that dp previous. This previous can go from 0 to k also, means 0 to k minus 1. This can be here, maybe here, maybe here. Not necessary. It just one element behind. So the DP relation in this for this problem is dpij is equals to dpji plus 1. So let me explain it in more detail. So J is the current value we are exploring, current last value. If we include this current value in the subsequence, then what will be the largest length possible for the sequence? So we explore I for all previous, like any uh, 0 to k minus 1 values, means k minus 1 modulo. The explored value will be only modulus between 0 to k minus 1. So dpij means modulus of previous and modulus of current. Modulus of previous and modulus of current. In this sequence, we need to find modulus of j. Let's say a1, a2, a3, a4, a5, a6. So if this is the current j and this is I, so previous modulo value will be j only. Before that y only, j only, I only. That means alternate values, modulus value are same. So if the current value, modulus value is j, so previous modulus value is I. So uh, third element from the last modulus values would be equal to j. There, that's why we are uh, if we want to include this in the array in the valid sequence, in that case we have to means till here its length is something, let's say L. So if we want to add this in the sequence, we need to like gi means the ji value means by including how much count we got, we will add one element in this value. That's why dpij is equals to dpji plus 1. So I hope you guys have understood this. Let me explain this with a example. Let's take the second example in the given sample test cases. So here k value is equals to 3. So modulus after modulus, these value will be in the range of 0 to 2. So we will take an DP array of size k cross k 0, 1, 2, 0, 1, 2. So initially all the values are zero. Assume these are all are zero. So first element is one. So here j is equals to one. Now we will traverse from I is equals to 0 to 2. That is 0 to k minus 1. All values we will traverse. Considering if previous value is 0, like if it is a 0, 1 pair, if it is 1, 1, 1, if it is 2, 2, 1. So all these combination we will fill the value if we want to include this in every possible, like if the previous sequence is like this or previous sequence is like this, it's like this. So we fill all these values. So dt 0 1, dt 0 1 is this one will be equal to dt 1 0 plus 1. 1 0, that is 0, so it will be 1. dt 1 1, dt 1 1 plus 1 1 1. Now again, modulus value, modulus 4, modulus 3 is equals to 1 only. So this sequence only, this time again. So dp 0 1 is 1 0, is still 1 0 is 0, so this will be 1 only. dp 1 1, dp 1 1 plus 1. Now the dp 1 1 was 1, so it will be 2. dp 1 2 1, dp 2 1, that is 1 2. Here it is 0, so it will be 1 only. Next, the modulus is 2 only. In that case, now we have to fill 0, 2, 1, 2, and 2, 2. So 0, 2, 0, 2, we need a sequence like this 2, 0. So we will check 2, 0. 2, 0 is 0, so it will be 1. 1, 2, we need 2, 2, 1, 2. So we will check 2, 1, 2, 1, that is 1. So it will become 2. And 2, 2, 2, 2 is 0, so it will 1. 3, it is 0. So now this is 0, 0, 0 for 1 here. So 0, 0, 0, 0, 1, 0, 2, 0, 0. So we have to fill this 0, 0, 0, 0 plus 1, 1, 1, 0, 1, 0, 0, 1, 1, 2, 2, 0, and 0, 2, 2. So now we have reached here. Again 1. We have to fill 1 0. 1 0 will become plus 3. 1 1 3. And 2 0. 2 1. 2 1 would be plus 1 2. 1 2. That is 3 becomes 3. Now we have this one again. So 1 again, so we have to form 0 1, 0 1 1 2 1. So 0 1 is this only. 0 1 1 0 2 3. Not no change. Only 1 1 1 3 1 second. So the last one we were exploring here. One is already three, so it will become four now. Mm. Two what one two is two, so it's still four. So the maximum length of any subsequence is four. That will be your answer here. So we are trying to include this element considering any modulo can be its previous element. So we keep considering 0 to k possibilities for every element and try to include that in that subsequence. So in this way, we find at any point we count is increased, we update our result value. In this way, this problem is solved. It was a quite good question. Hopefully, you guys have understood. And thank you for watching. Let's meet tomorrow. Bye bye.